Guess I'm loud enough too. JCV from Aptima. I'm the Navy Portfolio Manager, and I'm supporting Jordan Koger here, who's going to explain to us and walk us through one of our exciting capabilities, NeuroAdapt. We're located back over here in the show floor. We have another of our technologies, adaptive technology, ProPal. Okay, so Aptima, we're a small interdisciplinary company that's based nationally. We're focused on human engineering. Been alive since 1995, working closely with all the services. We have commercial government contracts, and we're looking to expand our base through activities like this. Our work centers on the human experience in highly technical environments and the tools and technologies that they use to achieve their objectives. We are nationally based, like we talked about, headquartered in Woburn, Massachusetts, which is about 20 minutes north of Boston, if you're not familiar with the area. We have our office here in Orlando. We have a DC office, Dayton, Ohio, for Air Force work. And we're very proud of just achieving our 1-year anniversary to expansion into Puerto Rico. So looking to continue to do that. Thank you. Yeah, exactly, expanding. So just rolling off of thesis, again, lots of great context, and I want to thank the Tech Road for this wonderful event, 3 years running now. Our approach to business is to deliver the innovative, impactful tools that humans can use to achieve their objectives in the workplace, like we talked about. We focus on understanding how they tackle the problems to solve today's challenges in the work environment. Our philosophy to work pretty much creates a wonderful culture that guides us to achieve our mission, which you see up there, which is to optimize and improve human performance in mission-critical technological intense settings. We apply deep expertise on how humans think, how they learn, and how they perform today's challenges to achieve their objectives. Again, I'll turn it over to Jordan Koger, who's going to talk to us about an exciting technology focused on ATC, but adaptable to various environments. So with that, Jordan.
Yeah, thank you. All right, so the NeuroAdapt project in a nutshell is basically that we want to create an adaptive training method for ATC controllers as they are either progressing through ATC school or if they are out in the field needing to expand on their capabilities. We are in a phase 2 right now. We are looking to either do a phase 2 plus up, or we are looking for transition partners here who could use any of the components that we have as part of the NeuroAdapt solution and partner with them. So some of the challenges that we have for ATC is that it's a very complex environment that they work in. There are multiple planes that they have to keep track of. They have to keep track of the weather. You know, everything is moving at different speeds, and any mistake that they make is extremely catastrophic. So in order to learn all of the skills that they need, the ATC school has a very steep learning curve. This means that a lot of the students end up washing out, and the graduation rates aren't as high as we'd like them to be. One of the reasons for this is that the ATC trainers do not have insight into the headspace of the trainees. So what we want to do is give them a little bit more of an objective reading of what is going on inside of the heads of the trainees as they're going through. So what we employ in the NeuroAdapt architecture is the Sense, Assess, Augment framework. We ingest and synchronize multimodal data on the subject as they are going through the training. We assess that information, and then we give feedback to the instructor so that they can adapt the simulations in order to get the best results. For the NeuroAdapt, we have a 3-pronged input. We have biometric sensors, which I will don in a minute. We have survey tools before and after so that we can understand what the trainee is feeling. And then we also have task-related input. So if the trainee is making mistakes or if they need assists. There's two components to the NeuroAdapt feedback. There is the inner loop and outer loop. So the inner loop is in a single simulation. The trainer gets feedback on how the trainee is doing and can adapt the simulation accordingly. So they can either remove planes, add planes, if they need to stress out the trainee more, or if they need to back off the stress a little bit. And then we have an outer loop adaptation as well, which is over time, understanding how the trainee is performing in different environments, where they are proficient and where they might need some more work. So what we have is a heart rate monitor, and we have an EEG headband. I know EEG headbands normally get a bad rep, but here I just donned it. So that's how long it takes to put on our sensors that we use. And what we are able to do with this is we are able to understand the headspace of the trainee. We can see if they're in a stressed out environment or if they're prone to making mistakes. So I like to give the example that at the end of the game, you would want Michael Jordan taking the shot rather than Jordan Coker. Even though we'd be experiencing the same level of stress, he is going to be in a cognitively better state than myself and more likely to make the shot, also taller. And then we also get feedback on a tablet using a survey tool. So as the instructor is going through the training with the trainee, they are able to mark anything where they have an error, if they need an assist, and all of this is synchronized in real time. We then get biofeedback based off of how the trainee is doing to the instructor. So this is very important for understanding if the trainee is likely to make mistakes. Ideally, we would want them in that low environment, the low meaning the green here. So the low would be if they're not overloaded. We like to say that the red is kind of whenever somebody is on the verge of spiraling and are going to end up making a lot of catastrophic mistakes. Over time, what we would hope to see is that the trainee gets more time in that green where they are making smart decisions whenever it comes to air traffic control. This is a two-pronged study. We're working with the University of Chicago, and they're doing an in-the-lab version of the ATC training. And then we also have a field study where we've worked with Tyndall Air Force Base. We've already completed our first data collection. We are using that to improve our algorithms, and then we'll be going back later this summer. And I'm getting the hook here, so I appreciate your time. And if you have any questions, or if you think that any of the components of this project can work with you, please come see us at our booth. Thank you.